Have you ever wondered how industries can manufacture chemicals without harming people or the environment? That's exactly what green chemistry is all about. In today's lecture, we'll understand green chemistry, its objectives, principles, applications, and how proper waste management helps build a cleaner and more sustainable future. By the end of this session, you'll have a clear understanding of these concepts from both an academic and practical perspective. So, let's begin. Green chemistry focuses on making chemical processes safer, while waste management ensures that the waste produced is handled responsibly. Together, they play a major role in protecting our environment and supporting sustainable development. Let us first understand green chemistry. Green chemistry is a branch of chemistry that focuses on designing chemical products and processes that reduce or eliminate hazardous substances. In simple words, it aims to make chemical production safer for both people and the environment. Now let's look at its importance. Green chemistry helps reduce pollution, conserves natural resources, and promotes sustainable industrial development. Now let us discuss the objectives of green chemistry. The first objective is reduce the use of toxic chemicals. This means replacing harmful chemicals with safer alternatives whenever possible. The second objective is to prevent the formation of chemical waste. The goal is to avoid generating waste instead of treating it later. The third objective is to use renewable raw materials. This encourages the use of resources that can be naturally replenished, such as plant-based materials. The fourth objective is to improve energy efficiency in chemical processes. Chemical reactions should use less energy while maintaining good performance. The final objective is to design safer chemical products. Products should perform efficiently while remaining safe for humans and the environment. Now let us understand the principles shown in this diagram. This diagram summarizes the 12 principles of green chemistry. They include prevention of waste, atom economy, safer synthesis, safer chemicals, safer solvents, energy efficiency, renewable raw materials, reducing unnecessary derivatives, catalysis, product degradation, real-time analysis for pollution prevention, and inherently safer chemistry for accident prevention. Remember these principles because they are frequently asked in examinations. Now let us study the first 6 principles of green chemistry. The first principle is prevention. It is always better to prevent waste than to clean it up after it is formed. The second principle is atom economy. Chemical reactions should convert as much of the raw material as possible into the final product, reducing waste. The third principle is less hazardous chemical synthesis. Chemical processes should use and produce substances that are less toxic. The fourth principle is designing safer chemicals. Chemical products should perform efficiently while remaining safe for humans and the environment. The fifth principle is safer solvents and auxiliaries. Whenever possible, harmful solvents should be avoided or replaced with safer alternatives. The sixth principle is designed for energy efficiency. Chemical processes should use less energy and preferably operate under normal temperature and pressure conditions. Let us continue with the remaining principles. The seventh principle is use of renewable feedstocks. Renewable raw materials should be preferred over non-renewable resources like petroleum. The eighth principle is reduce derivatives. Unnecessary processing steps should be avoided because they increase waste. The ninth principle is catalysis. Catalysts are preferred because they improve reaction efficiency and reduce waste generation. The 10th principle is design for degradation. Chemical products should naturally break down into harmless substances after use. The 11th principle is real-time analysis for pollution prevention. Chemical processes should be monitored continuously to prevent hazardous substances from forming. The final principle is inherently safer chemistry for accident prevention. Chemical processes should be designed to reduce the risk of fires, explosions, and toxic releases. Remember these principles because they are frequently asked in examinations. Now let's look at some important applications of green chemistry. The first application is production of biodegradable plastics. These plastics decompose naturally and help reduce plastic pollution. The second application is the development of eco-friendly pesticides. These pesticides are designed to control pests while causing less harm to the environment. The third application is cleaner food processing technologies. Green chemistry helps industries produce food using safer chemicals and less waste. The final application is safer pharmaceutical manufacturing. It promotes the production of medicines through cleaner and more sustainable manufacturing methods.
Now let us move to the next topic, waste management purpose and strategies. First, let us understand waste management. Waste management is the systematic control of waste generation, collection, transport, treatment, and disposal, aiming to minimize environmental impact, protect human health, and conserve resources. In simple words, waste management includes every step from the generation of waste to its safe treatment and disposal. The main aim is to protect both our environment and human health while conserving natural resources. If you observe the figure, you can see different types of wastes such as organic, paper, plastic, glass, metal, e-waste, and mixed waste. This reminds us that proper waste segregation is the first step towards effective waste management. Now let us understand the purpose of waste management. The first purpose is reducing waste generation. This means minimizing the amount of waste produced by using resources more efficiently. The next purpose is protecting the environment. Proper waste management helps reduce air, water, and soil pollution. The third purpose is conserving natural resources. By recycling and reusing materials, we can reduce the use of fresh raw materials. The next purpose is preventing health hazards. Proper handling of waste helps prevent the spread of diseases and protects public health. Finally, promoting sustainable development. This ensures that development takes place without affecting the needs of future generations. Remember this important point. Proper waste management helps reduce air, water, and soil pollution and improves overall public health. That is why waste management is essential in every industry as well as in our daily lives. Now let us discuss the first waste management strategy: reduce, reuse, recycle. 3R principle. The 3R principle is the foundation of waste management. Let us understand each one. Reduce. Minimize the amount of waste produced by using fewer resources. In simple words, we should avoid unnecessary consumption so that less waste is generated. Reuse. Use products multiple times instead of discarding them. Instead of throwing an item away after one use, we should try to use it again whenever possible. Recycle. Convert waste materials into new products. This helps recover useful materials and reduces the amount of waste sent to landfills. For example, recycling plastic bottles, paper, and metal. These materials can be processed and converted into useful products again. If you observe the figure, it clearly explains how reduce, reuse, and recycle work together to minimize waste generation. Remember the 3R principle because it is one of the most important concepts in waste management. Next, let us understand composting organic waste. Composting is the biological decomposition of organic waste such as food scraps, fruit peels, and vegetable residues by microorganisms. In simple words, microorganisms naturally break down organic waste and convert it into compost. The next point is produces organic fertilizer, compost. The compost produced can be used as a natural fertilizer for crops and plants. The next point is improves soil fertility. It adds nutrients to the soil and supports healthy plant growth. The next point is reduces waste sent to landfills. As more organic waste is composted, less waste reaches landfill sites. A good example mentioned here is, in food industries, vegetable peels and fruit waste can be converted into compost. Instead of treating them as waste, they become a useful agricultural product. Now let us move to waste segregation. Waste segregation means separating waste materials at the source into different categories. When waste is separated properly, recycling and disposal become much easier. The first category is biodegradable waste. food waste, plant materials. These materials naturally decompose with the help of microorganisms. The next category is non-biodegradable waste, plastics and metals. These materials do not decompose easily and are usually recycled. The last category is hazardous waste, chemicals and medical waste. These wastes require special handling because they may be harmful to people and the environment. Finally, remember this important point. Proper segregation helps in efficient recycling and safe disposal. That is why waste should always be separated at the source itself. Now let us understand energy recovery from waste. Energy recovery involves converting waste materials into usable forms of energy, such as electricity, heat, or fuel. Instead of simply disposing of waste, it can be used to produce useful forms of energy. Now let us look at the methods mentioned here. Biogas production from food waste. Food waste is converted into biogas through microbial activity. Waste to energy incineration. Waste is burned under controlled conditions to generate energy. Anaerobic digestion. Organic waste is broken down in the absence of oxygen to produce biogas. Finally, this process helps reduce landfill waste and produce renewable energy. If you observe the figure, you can see how waste enters the anaerobic digester and is converted into biogas, electricity, heat, fuel, and other useful products. This is an excellent example of converting waste into a valuable resource instead of simply disposing of it.
Thank you. With this, we have completed today's lecture on green chemistry and waste management, purpose and strategies. I hope this session helped you understand the concepts of green chemistry, waste management, and the different strategies used for sustainable environmental protection. If you found this lecture helpful, please like the video, subscribe to the channel, and share it with your friends. Thank you for watching, and I'll see you in the next lecture.